Hello, good morning. I'm Deepak from MentorCamp. So, with me, my colleague Mr. Nimal will be participating in this webinar.
Yeah, hello, Deep.
First of all, thank you very much for coming and showing your interest in this webinar. This will be the first webinar within our group of webinar. So, more things will be coming in upcoming webinar from MentorCamp products. So, how to interact with the presenter? So you can interact with the presenter by live chat, and you can drop us a mail for asking question by offline and answer our queries. And you can also have this session recording will be given to you afterwards. So this is the short video of our MetaScam. So this we presents you the new FikusST 20. So what we'll be learning today? So mainly we are concentrating on CAD environment. So we are going to have a CAD environment features today. So CAD environment, what should one achieve after this webinar? Uh, you can see what are the helpful CAD functions, advanced fixed geometry functions, cutting plane and project boundary contours, surface selection, gear features, levels, UCS and filters, and merging geometries, groove, projection of element on active plane, and repetition and extrusion. These are the things you'll be achieving after this webinar. So first we comes to fixed geometry. How fixed geometry can be worked? So if you import some DXF or DWG files, so some DWG files or DXF files will have some discontinuity, overlap, loops, duplicate elements will be there. So these kind of things can be fixed by using fixed geometry. So fixed geometry allows to repeat duplicate elements, discontinue elements, and overlap. So we'll have a check in our live demo. So this is our Ficus environment. So I'm selecting the duplicate geometries. Okay, let me select properly. Okay, after selection you can see we have two selected elements. When we go for fixed geometry from the tool user function, we have an option called repair duplicate geometries. If we confirm that, we can see only the single element. It will combine and join the entire element. Same as like this, we have discontinuity geometries. If you search for discontinuity geometries, you can see there is a small discontinuity over there. So you can see here some discontinuity is there. So when we go for fixed geometry, repair tools, and when we select join entire element with a single segment, when we confirm the entire geometry, the discontinuity will be not available. So it will join entire element in the one segment. So same as overlap, you can find as two overlapped lines here. So green color indicates the overlaps. So now I'm going for the overlap geometry. I'm selecting all geometry and confirming. So here now we have only single element. So like this, you can see the overlap geometries. So next is repair loops. So when we have to remove our loops to single element, so in this case you can repair all the loops in one click. So let's see how we can go. Okay, let's go. Let me open my custom. So now we have loop geometry. So I need to repair all the loops in and make a single segment. So how we can do it? So I'm clicking on the circle. I'm checking the line and the radius. So when we go for loop, I'm giving the minimum length to be repaired. So I'm selecting entire geometry and conforming, so we can see all the loops has been modified into single segment, and it has created a single line. So next we'll go for new cutting planes. So Mr. Nirmal will be taking now.
Hello all. So, okay, now let us learn about cutting plane. What is this cutting plane? Most of us are aware of this cutting plane, but still, let me just explain you what it is. In order to derive a 2D plane, in order to derive a 2D profile from a 3D profile at any given Z surfaces, we use cutting plane. We have an option called as cutting plane. So we'll see now with a small demonstration how we can use that cutting plane. So here I'm using a solid block here, and I'm selecting the cutting plane from wireframe mode. In wireframe mode, you can see that a window is open with the cut XY plane, and this is to indicate that it is in XY plane. Now let's see in a solid mode. When I adjust this bar over here, I can set the Z level for the solid mode where I need a cutting plane. Else, I can define the cutting plane value, Z value, and create a cutting plane. I can name the cutting plane. When I click on the cutting plane, I can see that in my levels, there is the 10 cutting plane created. Further, when I increase this bar at a different Z level, here, okay, I create another layer. I will rename this. And create a cutting plane. So my second cutting plane is created in the levels. Again further, I will increase it further and create another Z level, say 24, and I'll check mark the cutting plane and define it as 24.0. Z equal to, okay. So when I click on the cutting plane, you can see a third cutting plane is also created in the levels. When I switch off the model, I can now see how I have created three different cutting planes at three different levels. Now I can switch off the layers, whichever layer I want to hide, and work on the rest of the cutting plane. Okay. So next thing what we will see is we'll see project boundary contours. What is this project boundary contours? Project boundary contours is like the cutting plane itself, but there is one small difference in this. Here, what we do is we project the boundaries of the solid here, which are in a different levels. We'll select these surfaces of the model which are in different levels, and we project it to the active plane as shown in the image. So let us now see a small demonstration how to do it. So in this exercise, what I'm going to do is I have selected this model and I will use the boundary selections. I will use the surface selections to select the surfaces. I am using a surface tool, project to boundary surfaces, and here first I will change the UCS. I will make the UCS to an active UCS just for an example by giving the values in the Z. I can change a new UCS. I created a new UCS. In the UCS I can see I created 0 as UCS which will be active now. So this is my active plane. Now my intention is to project all the boundaries of the surface to this active plane by using surface tool, project to boundary selection. Here I will be using UCS selection where I have 0, which I'll make it, which I'll select it, and I'll select the axis which needs to be projected. Z axis needs to be projected. So these are the surfaces at different levels. What I'm selecting to project onto the active plane. So after my selection, when I apply it, I can see now all boundaries have been projected to the active plane. So this way, we can also project any surfaces to the active plane. Next, let us see how we can create and how we can use the surface tools present in FikusST CAD to do the cylindrical surface. Here, we have also introduced a tilt angle in the cylinder so that you can use it as an ejector, which are commonly used in mold industries. So let us see now how we can create a surface. So in this exercise, I'm using surface tool cylinder where I'm giving the height and the radius. And once I click it, I can see a surface cylinder has been created. Okay. So similarly, this is in the front view. Now, if I want to have a tilt in the cylinder, I have an additional tilt angle which I can give it over here. And when I click it over here, I can see that there is a tilt in the angle. So this way I can create the surface cylinder also with the tilt angle. Next, in the surface tools, we will see about how we can revolve using the surface tool. So for this, I will start with an exercise. Okay. Here I'm drawing a 2D sketch. I'm using the line tool to draw a 2D sketch for a cylindrical surface which I want to revolve in Z axis. So for this, I'm just giving some values. Okay. And then the final value. Okay. Now our profile is completed. Now I want to revolve this on Z axis using UCS method. So I'll go for the revolution and I'll use a UCS method. I'll select the axis, which is Y. Y axis is what I want to revolve this. And I'll select the curves. This is my curves. So as soon as I click on it, I get the revolved surface. Now let me show in 3D mode. So in wireframe mode, I can see a revolved surface has been created. This is how we can use a revolution uh, tool, surface tool, to revolve and 2D sketch on any axis. So next, let's see how we can use surface tool to create a cone. So for this, I'll use one exercise. Okay. Here I'll use a surface tool with cone, with top radius and bottom radius I have given and the height I have given. Initial angle and angle is a simple cone which I clicked, and according to the radiuses, you can see top it has taken the radius, top radius and bottom radius. Now I am changing the radius value, maybe 0, and height also 45. Radius value also I have changed. Bottom radius also have changed. Initial angle, now I'm giving an initial angle. I want to start from 10 degrees and complete at 3 degrees. So cone has been created with 10 degrees initial angle. So this is how we can make use of the surface tool to create conical surfaces. So for my next exercise for surface tools, what I will use is create surface tool using two elements with correspondent lines. Let's see how we can use the correspondent lines between the two elements to create a surfaces. So for this exercise, I have chosen this profile where I'm going to choose correspondent lines. I can set tolerance value and I'll set the elements. This is my bottom element and this is my top element. So the elements are selected. Now it is prompting me to select the corresponding lines. This in front view, I use the box method to select all the corresponding lines. And when I click OK, a surface is created. This is how easily we can create any surfaces with using correspondent lines. So this way we can make use of all the surface tools to make various profiles. Next, let us see about the gear module. There is a module in Ficus called as gear module where you can input the gear data and create a simple spur gear. So let us now see how we can create a simple spur gear using this gear module. For this gear module, you can go to tools and select the gear tool. A gear window is open where you can select gear modules according to pitch, number of teeth, and here you can select the limitations, either internal, external, or you can fit in the values, number of teeth and other such things. And also bottom, there is an option for overprint measurement value, where you can input overprint measurement value. And there's a window here where you can add the root and the crust height, the pitch diameter. And when you click on the drawing area, according to the data input, gears have been generated. This is normal spur gear, and further CAM process can be done on this. So this is how easily we can make the gear profiles. Levels. So another important features what is available in FikusST 20 is levels. Levels, why do we use levels? When we import any 2D sketch from any background such as AutoCAD or any other CAD environment, it imports along with the levels. There are certain levels imported such as dimension levels, color levels, or hatchet lines levels, and other such levels have been imported. Not all features are necessary to do it. Not all features will be useful to do the CAM process. Might be we may require. In such conditions, we may require to hide certain levels or create certain new levels for us to use. Let us see in an exercise how we can do it by creating levels. In this exercise, I have this profile sketch with dimensions. In levels, you can see there are dimensions and draw. When I click on dimensions, when I close on dimensions and draw, the particular levels is hidden. I have an option to create a new level where I can rename this new level as start hole. Start hole. Okay. And I am defining, I'll keep this as active, and here start hole, I want to define a start hole. So I'll select this small circle over here, which will be start hole. When I click enter, and that is become a start hole there. I can hide it or I can activate it according to my usage. So this is how I can create a new level. Here I have an option to delete the levels also. If I do not require that, I simply have to select it and click on delete. So when I click on that, my level is deleted. So this is how you can create a new level, assign a new level, delete the new level, and also rename the new level in Ficus ST20. So next, let us see about how we can create the uses. The important feature of creating uses is like there are possibilities, there are necessities that the user might require an additional use case for his daily for his work. So how we can create a new use case by using use case method in Ficus ST20. Let us see now with a small exercise. So in this exercise, I have chosen this model where I'll use the, I create a boundary for this. I'll use 3-point method to create the UCS. I'm creating a boundary with 0 offset. And when I click on that, I get a boundary line for this. Now, by placing the points, by taking the 3 points UCS, I'll select the origin for the UCS. This is my origin, and this is my X vector, and this is my Y vector. By clicking on that, you can see that a new UCS has been created. But this is not any active UCS. You can see in the position tab. Now this, after selecting it to the tick mark, now this has become the active UCS. You can see the position bar. Now it has become the active UCS. Now I can delete all the unwanted boundary lines. This is one way of creating an UCS in any 3D or 2D profile. So I'll delete all the unwanted boundary lines. And now I'll use surface method to create an UCS. This is another way of creating an UCS. Now I'll select the YZ plane. I can see here, this is my X and this is Y. So I know that this is my YZ plane. So I'll click on this YZ plane. And next I want to select XZ plane. This is my XZ plane. So next it's asking me to select XY plane. This is my XY plane. So based on my selection, a new UCS is automatically created, which can be now activated by placing the tick mark. So this is how easily we can create UCS. If you want, you can also delete the unwanted UCS. Now, for example, this I do not want. I have deleted it. So I want to rename it. I can rename this. So this is the easy way to create UCS in FikusST 20. Let us see the third option called as filter creation. This is one of the important tool what we have in FikusST. Why we require filter creation? Certain times when we have a profile containing lot of entities, maybe we do not want to select all the entities. Maybe we want to select only by color, or maybe we want to select the entities only by shape, or maybe we want to select the entities only by diameter. So we need some tool to quickly activate or deactivate certain, activate, deactivate, or select certain entities in a given profile. So to do that, we have this filter creation. Let me just show you a small example. Here in this example, you can see here we have colors, entities, and diameters and line type. Here I'm creating a new entity by entity by element. So when I create it by element, now I can choose an element by selecting element characteristics. So this is the element which I have selected, and that is now which is activated. So you can see there it is segregated according to color, line type, line width, etc. So and it is now activated. When I select box selected, only the selected entity will be selected. So let me just create one more entity by color. So let me see how we can use color option to select the entities. Now I selected by color. This is the option where I can go by color and I'll choose the color which needs to be selected, and that's it. So this is now active color, and now when I select the box selection, it'll search only for those colors and that will be activated. So by colors also we can apply. Third one, let us try to apply by diameter. Can we apply filters by diameter? Yes. So third filter I am applying by diameter. So when I select, one second, diameter. Yeah. So when I select it, there's an option for selecting by diameter. It will ask me for the minimum diameter and maximum diameter. Maximum diameter I want to select 5R, which is 10 dia. So up to 10 dia, 0 to 10 dia, all diameters needs to be selected. That is now activated. When I select the box selection, now I can see only the 10 dia have been selected. There's one more option which we can select by line type. By line type, yeah. So there are different line types. So I want to select only the dotted lines like this. Yes. So the filter has been applied, and when I select box selection, only the dotted line types profile have been selected. So by this way, I can activate or deactivate any particular filters what I require. You can see now by color, only colors is selecting. By element, only the element is being selected. I can activate two filters, and only those two filters are activated, by diameter and by element. So like this, I can assign each filter for each element, and accordingly I can choose them for my CAM process. So this is how useful the filter option will be in FikusST 20. So
merge geometry. So this is the quick and easy process to trim inner entities and outer profiles. So let's have a look how it's going to be happen. So let me open the file. Sorry, create a rectangle with 15 and the base 40. Same way I'm creating another rectangle. So one circle I will be creating now. So by selecting the center point with maximum dia and confirm. So I need to trim this to one single element. In the modify, we have an option called merge geometry. So if you click on that, select the, it asks for select elements. So we need to select the entire element. Then if we confirm, it automatically trims the geometry and it creates the one single segment. So this is how the merge geometry will be processed. So next is the group creation. So in group creation, we can use single or 2-point selection. So let's have a look. So I have a rectangle and circle. Now I need to create a group for rectangle. So let's go for it now. So when we select rectangle option, which is in modify, let's go with 1 point. I'm selecting a rectangular with the height of say approximate of 5. So then the width is 10 mm and transition is 0.5 mm and radius in the corner I'll say as a 2. So now I need to pick an element. So what I need to do? So select the point and a reference point. So after selecting, it will ask the direction where you need. So at 1 point, if you click, that is the direction of the group creation. Same way, when we go for 2 point selection, same height, just I remove the transition or to 0 and radius to 0. So same procedure, select the element and after that select the start point of the group. So after selecting the start point, it will ask the end point selection. So when you click on the endpoint selection, it will say ask for the direction where it needs to create. So when you confirm the direction, it automatically create the group and you can apply and confirm to continue same process. So let's try for a circular thing. So now I'm giving the height of 5 and the diameter is around 15. Let's check the transition is 5 and I'm selecting the element. So circle is my element. After clicking, it will ask for the referral point. So I'm giving the referral for point for the group. So when I see the group is more higher, so then you can reduce the diameter if you want. So here I'm giving 8 mm diameter to reduce it. So no, it's looking some, I need some more big low. So I created 12 mm diameter with the direction I have confirmed it. So same way we can do it for random profiles also where you need a small blue option inside that. So you can create like this.
Okay. So let us see now how to project on active plane. Project on active plane. What is project on active plane? Okay. So whenever we import any CAD profiles, it may not be that all the profile may be in the same plane. There may be chances that the profiles are split in different planes. Okay, when we import it, so we get all the profiles imported, but it will be in a different planes. So there should be some tool where we can place all the profiles in a single plane. Okay, so we will see in a a small exercise how we can do it. In this exercise, we can see that there's this profile. When I tilt it, all the planes have been, it's in a different planes. It's a 3 different planes. Now I want all the elements to be in a single plane like this. So how do I do it? So I go to the modify. I have project plane option. If I want, I can keep the original, box selected, and tick mark. So all my elements are placed in the single plane. When I tilt it, I can see now that all are placed in the single plane. Now it is easy for me to do the CAM process. This is how we can project the planes onto a single plane. We can make use of this option. The next option will be repetition. So there must be the possibilities to repeat an object. So there are chances that maybe a small gear teeth you may have created, you may need to make a copy of it. You may need to repeat it. There may be a possibilities for that. So here, let me show you how we can use the repetition tool and do it linear or and radial repetition. So here for the exercise, one small profile I have created, which I'm going to repeat it linearly for 5 elements, one, first and last. And you can see now that it has been repeated to 5 profiles. So this is so easy to create and repetition profile in FikusST 20. So similarly, we will now see how we can extrude any profile to a given any 2D profile to a given height or any taper angle. So let's see with a small exercise now. So I'm using the same exercise, but now I'm using the extrusion tool where I'm giving the height 20 and taper angle I'm at about say 4 degrees. So lines, I'm selecting the element, and when I click enter, tick mark, you can see that a taper angle of 4 degrees to the height of 20 has been extruded. So this is how easily we can extrude any 2D profiles to any given height in Fikus 20 ST.
So if you have any question, and you can directly ask to us. So you can, I think the chat is going to be enabled. So where you can have a chat there, or you can ask direct questions. Okay, I think no questions. So let's go for next. So upcoming technical webinar will be held on next 31st of May. So there we'll be showing the powerful cam features and the new modules of Ficus, where you can see a lot of new features which has been developed in Ficus ST20, and you can learn a lot of things with coming webinar. So you can join on 31st of May. So any doubt you can ask Ficus, ask or drop a mail to ficussupport@metalcam.com, or you can also for a sales query you can directly contact to sales@metalcam.com, or you can directly drop a message to sasi@metalcam.com. So you will be having a survey after this, so don't forget to drop a survey, and it will be open in your browser. So thank you for your time and attendance. We'll see you on next webinar. Thank you.